All right, today our Tennessee State Standard, is still the same as we looked at yesterday. It's 8, EE for expressions and equations, C, 7B, solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. Now remember, this is what we're building toward. This is actually not what the lesson is about. The lesson covers a 7th grade standard that you saw on yesterday's lesson about working with integers. Your lesson objectives today, which you need to stop and write this down. I am learning to, number 1, add integers, and number 2, subtract integers. Now our vocabulary for adding integers: a sum is the answer to an addition problem. Commutative property just states that when you are adding or multiplying, the integers can be moved without affecting the answer. So if you think about every day you commute back and forth to school, commutative property, you're moving. Just like you move from home to school, commutative property in addition and multiplication says that you can move those integers without affecting the answer. Now, to model addition of same sign integers, you could do this on a number line. So if we start at -1, and then we add -3, which means we're going to move 1, 2, 3 places, and then we're going to move -2 from there, 1, 2, which would give us an answer of -6. To look at that with counters, first of all, when you're looking at counters, red is always negative. That stands for your negative integers. And you may see yellow. If we use 2-color counters, you will see a tan color or a green color when we're using algebra tiles later on. Those are for your positives. So if I wanted to model this with the 2-color counters, I would drag out 1 negative, and then I'm going to add 3 more negatives, and then I would add 2 more negatives for a total of 6 negatives, or -6. Now, I think y'all are pretty smart, and I think you can do 1 plus 5, and you can already tell me the answer. Need to be on pen. So we already know that 1 plus 5 equals 6, and I'm going to erase this part on the number line. That erased the whole thing, didn't it? So let's make that a little bit smaller. And we're going to start at 1. So if we start at 1 and then we add 5 positives, that's 1, 2, 3, 4, 5. That's our answer is 6. And I'm going to drag these back in so we're not confused. And 1 is positive, so I would drag out 1 positive counter, and then I'm going to add 5 more. That didn't work good, sorry. I'm dragging from the wrong one, it looks like. So 1, 2, 3, 4, 5. Sorry about that. But we do have 6 positive counters. Now, the hot air balloon with integers, we're going to look at that tomorrow in class together. These are your turns, so go ahead and work them. You'll have to stop the video, work them out, and be ready to talk about them tomorrow. Let's get rid of these browsers so we don't have that coming out. So, in the examples that we've done in the your turns, what can you infer about adding same sign integers? Devise a rule for adding same sign integers. So what I want you to do right now is think about what rule you could come up with so that you didn't have to use a number line or you didn't have to use two pillar counters. So take a minute to do that. All right, so I think maybe we'll look at the rule tomorrow together. So I want you to be thinking about what the rule is for adding same sign integers. All right, so quick review. We're going to look at that tomorrow because we didn't talk about the rule. So this is a review. What is absolute value? It's not on your notes. You don't have to write this down because it's on your notes from yesterday. Absolute value is the distance from the number to 0, and that's a vocabulary term that you need to know. All right, matter versus antimatter is a video that we're going to watch together in class. All right, now to model addition of different sign integers, and we're not going to use the number line on this one, we're just going to use the counters. So 5, that's a positive. What color do I drag out? Well, remember, yellow is positive, so I'm going to drag out maybe, or maybe not. All right, so guess what? We're just going to draw. So I would draw 5, and I'm going to have you doing this on homework, so it's not going to hurt us to draw. All right, 5, but then I want to add -2. So I'm going to do these in red. Five plus -2. Well, let's stop and think about what a positive and a negative, when we put them together, will do. And this is another vocabulary term. A zero pair is an integer combined with its additive inverse or opposite to make 0. So, positive and negative, that makes 0. It cancels out. Positive and negative makes 0. It cancels out. So that would equal 3. But now, one more important fact that you need to know. We don't ever want to see two signs. So we're going to get rid of one of those signs. If the signs are different, we're going to make that negative. So that really says 5 minus 2, which is much easier for you to see that is 3. Now we're going to do this next one, and we will draw it out. So I have a -1 and +8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. We know that negative and positive cancels out. That gives us 7 positive counters. But let me show you something else. We can box in our terms so that you can see this as an addition problem, and we can use the commutative property. So if you will draw a line in front of this sign, these two numbers are what you're adding. So that really says 8. If we switch them around, you can write that as 8 plus negative, different signs, plus -1. And that is much easier to see. All right, once again, we'll look at the hot air balloon integers tomorrow. Here's a your turn, and I want you to draw pictures. Draw circles with, you don't have to use different colored ink, but draw the circles with plus signs and minus signs, and be ready to discuss them in your answers tomorrow. Make sure that you cancel out your zero pairs, which makes 0. So adding different sign integers. Given our previous examples, what can you infer about adding different sign integers? Devise a rule for adding, and that should say different. So let's just mark that out and put different sign integers. All right, now the last thing that we're going to talk about is subtracting integers. In our vocabulary, a difference is the answer to a subtraction problem. And an additive inverse is what you add to a number to get 0. It's a number's opposite. Remember, we talked about zero pairs. So 1 and -1 are additive inverses. 7 and -7 are additive inverses. So now we're going to model subtraction, and I'm just going to go ahead and draw these. And I always like boxing in my terms. So once I box these in, this is really an addition problem. I'm adding -6, and then I'm adding a -3. So -6. Oh, no. I want to do this in red. So -6, 1, 2, 3, 4, 5, 6. And then I'm going to add -3 for a total of -9. All right, and then remember, we do not want two signs together. We just want one sign. Now, before we talked about if they were different, you make it negative. If they're the same, the sign is going to be positive. And one way to look at this is if you connect these two negatives, it becomes a big plus sign. I'm going to erase that because I'm also going to show you what maybe you've seen in 7th grade. Some 7th grade teachers also tell you when you see two of those, change them to pluses. So either way, you can make it a big plus sign. So now we have -7 plus 15. Now I'm not going to draw all those counters because that's a lot. I don't really want to draw those. But remember, if we box these in, it's an addition problem now. We can swap those around and say 15 minus or plus -7. We don't put the plus sign. That equals 8. That's a little tough. This is probably the toughest ones. Hot air balloon integers we will look at together in class, and maybe it will help you to understand a little bit better. Let's see if I can grab this and drag it over. And then there are the your turns. You can choose whether to draw pictures or not on those. Just remember, if you have two signs, if you have two signs together, you need to make it into one sign. And we'll look at those answers tomorrow. Finally, I want you to think about the examples we've done and the your turns, and what can you infer about subtracting integers? Devise a rule for subtracting integers. And that is the end of our lesson.